Newton's third law states that if two objects interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1, and that these forces are opposite in direction. A simple way to remember Newton's third law is to remember that forces always exist in pairs. That is, for every action, there is an equal and opposite reaction. The hammer exerts force on the nail. The nail resists the force. Newton's third law asserts that forces always act in pairs. For example, a car accelerates by causing its wheels to turn and push against the road. It is the force of the road pushing back against the car that makes the car go. Note that the forces are simultaneous. The car puts a force on the road at the same time that the road puts a force back on the car. The forces act in pairs and have the same magnitude, but it is a mistake to think that the forces together would cancel each other out. The force on the car makes the car accelerate. And the force on the road, which is firmly attached to the earth, makes the earth accelerate, although only by a very small amount. Adding the force on the road and the force on the car does not make sense because the forces are applied to different objects with different observed results. A force on the earth doesn't affect the car, and a force on the car doesn't affect the earth. Newton's third law holds for non-contact forces as well. Consider the effect of the earth's gravity on a paper airplane. When the earth pulls downwards on the airplane with a force of 5 newtons, the airplane pulls upwards on the earth by the same amount.